Hello everyone, welcome back to your physics class. This is your physics teacher. Hope you all are well, and I hope you all have understood the measurement of mass using beam balance, physical balance and electronic balance as I have explained in the previous video. Now today we are going to study about the correct method for measurement of mass, how we can measure mass accurately. Because whenever we measure mass of an object with any of these instruments, we do some mistakes. So for accurate measurement of mass, there are some precautions to be followed, otherwise the results obtained may be wrong. Now firstly, how we can measure mass accurately by using beam balance and physical balance. So here are some precautions to be followed. First one is, before starting with the measurement, make sure that both the pans are empty and the beam lies horizontal, indicating equal mass on both sides. Means, whenever we are going to measure mass of an object, either with beam balance or physical balance, we should make sure that both the pans are empty and the beam lies horizontal. It should be horizontal, it should not move up and down, which shows that equal mass on both the sides or equal mass on both the pans. Then secondly, we should not put wet and hot objects in the pans, because wet and hot objects can bring a change in the actual mass of the object. Then the third one is, the beam should not touch any other object in its vicinity. Vicinity means that nearby to beam balance there should not be any other object which is touching it, because it can bring a change in the mass of the object which is placed in the beam balance for the measurement of mass. Then next one is, the object to be weighed and standard masses should be put in the pan gently. The object whose mass is to be measured and the standard masses should be placed in the pans very softly, very gently. And while measuring, when nearing the actual weight, the masses should always be tried in descending order. Means we should try the standard masses from larger masses to the smaller masses. And the last one is, wait and give sufficient time for the pans to get stabilized. What is the meaning of this line? Means if we have done a prior measurement before going to start the next measurement, then there can be movement of the beam up and down. So we should give some time to get stabilized. We should give some time for the pans to get stabilized. Now next one is electronic balance. Now, as we know that electronic balances are very sensitive, that means these can measure even very small masses of the order of milligrams. So one must follow these precautions while using them. First one is, the balance should be kept on a horizontal, stable means which is not moving, and dust-free surface. Secondly, make sure the range setting of the balance conforms to the mass being measured. Means if we are keeping an object whose mass is in kilograms or in tons, and the range of this electronic balance is up to grams, then it is not possible to measure the mass of that object with the help of this electronic balance. So we should make sure the range setting of the balance conforms to the mass being measured. Then next one is, wet or hot objects should not be put on the pan. Again the same, because the wet or hot objects can bring a change in the measurement of mass. Then before measurement, ensure that the pan is free from the remains of any substance. What is the meaning of this line? Means कि अगर हमने पहले ही कोई measurement की है और तब हमने object में कोई pan रखा था, तो उसके अगर कुछ रिमेन्स रह गए हैं, मीन्स कि कुछ बचे हुए पार्टिकल्स पैन में रह गए हैं, तो नेक्स्ट मेजरमेंट करने से पहले हमें उनको रिमूव कर लेना चाहिए, बिकॉज उनका भी जो मास होगा वो नेक्स्ट मेजरमेंट में ऐड हो जाएगा. देन सेकंड लास्ट वन इज, द object whose mass is being measured should be placed on the pan gently. Again the same, we should place the object whose mass is to be measured very softly or very gently on the pan. Now next topic is units for measurement of mass. As we know, the SI unit of mass is kilogram, which is represented as kg. But besides kilogram, there are other units of mass like gram, milligram, quintal, metric ton, tons. Because to measure the mass of heavier objects, we use multiples of kilogram. that are quintal and metric ton. And similarly, to measure the mass of lighter objects, we use sub-multiples of kilograms, that are grams and milligram. So here are the common units for measuring mass. First one is the kilogram, then grams. What is the relation between kilogram and gram? We know that there are 1000 grams in 1 kilogram, or 1 gram can be written equal to 0.001 kilogram. Then next one is milligram. In 1 milligram there are this much kilograms, and we can convert kilogram to milligram. Then in 1 quintal there are 100 kilograms. And what is the relation between metric ton and kilogram? 1 metric ton is equal to 1000 kilogram, and it can be written equal to 10 quintal. Because 1 metric ton is equal to 1000 kilogram, and 1000 kilogram can be written as 10 multiplied by 100 kilogram, and we know that 100 kilogram is equal to 1 quintal, so it will be equal to 100 kilogram is equal to 1 quintal, so it will be equal to 10 quintals. So 1 metric ton can be written as 1000 kilograms, or it can be written equal to 10 quintals. Now here we have next topic, that is conversion of units of mass. How we can convert 1 unit of mass into another unit. So here you can see a table for the conversion of units of mass. These are the conversions, and these are the relation between the different units of mass. So firstly, if we want to convert kilogram to gram, we have this relation. We know that there are 1000 grams in 1 kilogram. Similarly, to convert gram to kilogram, we will follow this relation. 1 gram can be written equal to 1/1000 kilograms. Similarly, if we want to convert gram to milligram, we know that 1 gram is equal to 1000 milligrams. And for converting milligram to gram, we can follow this relation, 1 milligram to 1/1000 grams. Similarly, we know that there are 100 kilograms in 1 quintal. So by using this relation, we can convert quintal to kilograms. And for kilogram to quintal, we can follow this relation. Similarly, there are 1000 kilograms in 1 ton, or 1 ton can be written equal to 1000 kilograms. So these are the different conversions for units of mass. That means how we can convert 1 unit of mass to the other unit. Or we can follow a simple trick for converting the units of mass. Here you can see, if you want to convert milligram to gram, or gram to kilogram, or kilogram to ton, then you can simply divide it by 1000. You can divide the known quantity by 1000, and then you can convert milligram to gram, then gram to kilogram, and then kilogram to ton. For example, if you want to convert 10 milligrams to grams, then how you can convert? Simply multiply this quantity 10 by 1000. You will get that quantity in grams. So that will be equal to 1/100 grams. It will be equal to 0.01 grams. Similarly, you can convert the quantity from gram to kilogram by just multiplying by 1000, and then from kilogram to ton by dividing by 1000. Then if you want to convert ton to kilograms, or kilograms to grams, or grams to milligram, then you can simply multiply the quantity by 1000. For example, if you want to convert 5 tons to kilograms, then simply multiply by 1000. So that will be equal to 5000 kilograms. Similarly, to convert kilogram to gram, multiply by 1000, and then gram to milligram, multiply the quantity by 1000. Now next one, if we want to convert quintal to kilogram, or kilogram to quintal, then we can follow this relation. We know 1 quintal is equal to 100 kgs, and if we want to convert quintals to kg, then simply multiply that quantity by 100. Or if we want to convert that quantity from kg to quintal, simply divide it by 100. So you can follow this simple trick for conversion of units. Now we have some numericals based on the conversion of units of mass. So the statement of first numerical is Vivan wanted to buy 2 kilogram of sugar. He wanted to buy 2 kilogram of sugar. But the grocer's electronic balance, the shopkeeper's electronic balance displayed 1.950 kilogram as the result. Then how much more sugar will make up the desired quantity? Means we have to find out that how much amount of sugar has to be added to this amount of sugar to make up the desired quantity, that is equal to 2 kilogram. So the required mass is 2 kilogram, means Vivan wanted this much amount of sugar. But the amount of sugar that is displayed on the electronic balance is 1.950 kilogram. So firstly we have to find out the difference in the mass. The difference in masses is 2 kilogram minus 1.950 kilogram, that is equal to 0.050 kilograms. Means this much amount of sugar we have to add in this amount so as to get 2 kilogram of sugar. Or we can convert it into grams. How we can convert it into grams? We know that in 1 kilogram there are 1000 grams. So it will be equal to 50 gram. So 50 gram more of sugar will make up the desired quantity. That means 50 gram more sugar we have to add to 1.950 kilograms so as to get 2 kilogram of sugar. Now next numerical is which is less, 500 milligram or 5 gram. So in this type of numericals we have to firstly we have to make the units same. That means either we have to convert milligram to gram or gram to milligram. So let us convert this milligrams to gram. We know that in 1 milligram there are 1 over 1000 gram or 0.001 grams. So 500 milligram can be written, that is equal to 500 multiplied by 0.001 gram. So it is equal to 0.5 gram. So it means 500 milligram is equal to 0.5 gram. So out of 5 gram and 0.5 gram, which is less? Obviously 0.5 gram is less than 5 gram. So we can say that 500 milligram, which is equal to 0.5 gram, it is less than the 5 gram.